Okay, so this is a recording for Module 8 homework, and this time I'm going to do the proportion one, the inference for two population proportion. I'm going to do number 32. So number 32 says a sample of college seniors shows that 15 of 50 who own PlayStation 3 spent more than an hour a day playing games, comparing with 35 of 100 who own a Zoom Box 300. We want to test the claim that P1 less than P2 using a 0.01 significant level. So first on Excel, I actually have some template. So first I'm going to have my hypothesis. So the alternative hypothesis is going to be P1 equal to P2. So the proportion for playing PlayStation the proportion of people playing PlayStation do not different than the people playing Zoom Box. So I'm going to set 1 as my PlayStation, 2 as my Zoom Box. Then the alternative hypothesis is going to be P1 less than P2. So we have less people playing PlayStation than the people playing Zoom Box. So first, I'm going to already have my default that 1 stand for PlayStation, 2 stand for Zoom Box. So X1 is going to be number of peoples. For the PlayStation, I have 15 students out of 50, which is my N1. For my X2, which is my Zoom Box, I have 35 and 100. Then my P1 hat is going to be 15 divided by 50. My P2 is going to be 35 divided by 100. Actually, I just switched some of the template. I actually put P1 hat and P2 hat on the top. Actually, I need to figure out two more things, which is the P bar and Q bar. Okay. So in order for me to find the z-score, let me just show you the z-score formulas. In order for me to find the z-score, which is I need to have the P1 hat minus P2 hat minus P1 minus P2 over square root of P bar times Q bar over N1 plus P bar times Q bar over N2. So for the P1 and P2s, because of our null hypothesis, P1 minus P2 is always going to be 0. So on the side, I'm just going to type up my z is going to equals to P1 hat minus P2 hat over square root of P bar times Q bar over N1 plus P bar times Q bar over N2. Okay. So for my P bar and Q bars, Q bar is going to be 1 minus the P. So there's really nothing too new about the Q bars, but the P bar is going to be on the numerator x1 plus x2 divided by n1 plus n2. So back to the formula, I'm going to using x1 plus x2 divided by n1 plus n2. Let's just make it nicer. I want it to have less decimals. Then my z-score is going to be p1 hat minus p2 hat divided by square root of p bar times q bar over n1 plus p bar times q bar over n2. Once I have the z-score, I got negative 0.6123. I'm also going to align it to make it less. Then the question is talking about we're going to using 0.01 significant level. So alpha is going to be 0.01. Because our alternative hypothesis that we have P1 less than P2, that is a left tail. Then what I want is on the left tail, I'm going to have the areas 0.01. So left tail area is going to be 0.01. So I want to find the critical value, which is the corresponding z-score for the alpha. So since I know the area, my z-score, I'm just going to separate it. I'm going to say z star is going to be the norm inverse of the area 0.01, because using the cell, that's the probability. The mean is going to be 0, the standard deviation is going to be 1, since we're talking about the standard z-score. So I have the z-score is negative 2.326. So either way, you can see that the original z-score we just calculated is actually choose this one. It's actually really safe within the 2 standard deviation range. So we don't think z-score is too far away from the mean. Also, if we're comparing with the z-star, which is our critical value, we can see that the critical value is negative 2.3. So in order for us to considering low chance of happening or not usual, I do need to have a z-score is further away from the mean, like negative 2.3 standard deviation away from the mean. So based on those one, we can say that we are right here. We are failed to reject the null hypothesis. So we do not have enough evidence to say the population, the proportion between proportion of people, proportions are different between people or students play PlayStation and Zoom box.